Dependency injection is necessary if you are not coding spaghetti and you want to keep nice layers of separation in your Flutter app's codebase. The problem is that all of the libraries out there, such as getit or kiwi, are just service locators with no support or a very limited support for automating the registration of dependencies. Dagger solves it elegantly for native Android, and Angular is also known for its powerful dependency injection framework. Now, we Flutter developers can finally use something similar, the Injectable package, which is a code generator for getit. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to build an app which is very exciting, and it's a counter app, but it's not going to be just a plain old counter app, but we are instead going to use dependency injection to change its functionality. So now when I press this increment button, the counter is incremented by just 1 as usual. But if I go here, and this is, by the way, a starter project which you can get from the link in the video description, and also from the same link you can get all of the code written in this tutorial, find links to the libraries, and overall go through this lesson at your own pace. So once you have this starter project, you'll be able to change this counter repository, which is the production one, to be dev counter repository, import that, and we're of course going to take a look at how it's all implemented in just a little while, but let's just for now ignore all of the details. We have just replaced the production counter repository instance with a development instance. And what this does is that after we hard restart, so Ctrl+Shift F5, and now we increment, the counter will be incremented by 2 and not by 1. Of course, you can see that the starter project does not have any real dependency injection in place. Instead, we are just manually passing in the production repository, or in this case, the development repository. But let's now take a look at how it's actually all implemented. We have a counter change notifier, and if we open that up from the presentation layer, we can see that it takes in an iCounter repository. And otherwise, the counter change notifiers implementation is very simple. We have just one value field, and we have an increment method, and inside that increment method we increment the value field. What's different is that instead of adding constantly just 1 to the value of the counter, we instead get the increment from the counter repository. And counter repository is just passed in. We do this in order to have a nice separation in our code base, which will allow this code base to be testable and also maintainable. And what is up with this iCounter repository? Well, it's an abstract class which defines just one method, getIncrement. And this iCounter repository abstract class is implemented by the production counter repository, which has increment of 1. And then we also have dev counter repository, which has increment of 2. The issue with this project is that we are now using sort of a manual dependency injection where we just instantiate all of the classes manually right where they need to be instantiated, in this case inside main.dart. And of course, this is just a simple project, so instantiating classes manually is not really a huge issue, but as soon as your number of dependencies grows, doing this all by hand would become a nightmare. And of course, we could just use plain getit or plain kiwi, but that would not really help with cutting down on the boilerplate. Sure, the code would be more maintainable if we just used plain getit, but you know, you have to register all of the factories, all of the singletons yourself, and it just becomes a huge mess really quickly. And that's precisely why Injectable is so awesome. It allows you to just annotate classes and it will generate all of the getIt boilerplate for you, so you will save very huge amounts of time. And by the way, this tutorial assumes that you are at least a bit familiar with getIt or other service locators in general. So if you're not, just read up on them and come back to this tutorial. Okay, so let's now set up Injectable. We are going to go to pubspec YAML and we are going to add a few dependencies. Of course, it's going to be Injectable together with its generator, and we are also going to add getIt because this is what Injectable works with. The current version of Injectable is 0.1.0. This is the absolute first version, but it already works quite well, and I have a feeling that at least the basic API is sort of finalized. There may be some changes in the future, so I don't promise anything. If something doesn't work with future versions, just come back to this version and follow along with this tutorial with the version 0.10.0. We are using getIt 3.1.0, and then of course we are going to use build runner and Injectable generator as dev dependencies, and we are also using provider. With plain getIt, you have to register all of the factories and singletons. With Injectable, you just have to create the basic Injectable configuration method, which you are going to run from within main.dart. We're going to create this configuration method inside a new file, call it injection.dart. And inside of it, we are gonna create void configure injection, which is going to accept string environment. We're going to use this string to differentiate between our dev counter repository and the production counter repository. And this is just going to call a function which is going to be generated for us in just a bit. Its name is going to be init getIt, and it's also going to take in environment, which is a named parameter. And this also has to be annotated with @injectable init. Okay. Once we have that, we can now run code generation. So let's open up the console and we're going to run our favorite command, which is flutter pub run build runner watch. And also, just to be safe, I always include delete conflicting outputs as an option there. Once everything is generated, we are going to see a new file pop up, injection.iconfig.dart. Currently it contains only a blank init getIt generated method, and we also need to call it, or actually import this method over to our own manually written injection.dart file. This generated method will contain all of the registration of factories, singletons, and lazy singletons once we add the code and annotations to our classes. And then we could just pass in regular strings, string literals to this configure injection, but I am a huge proponent of not passing around magical string literals, or any literals for that matter. So instead of passing literals, we are going to pass in constants. We are going to get them from an abstract class, env for environment, and this is just going to define static const dev, which will be equal to dev, and then also static const prod for production. And if you are not familiar with constants in Dart, you can learn everything you need to know about them from a tutorial from the card in the corner. Having all of this, we can now go to main.dart, and from the main method, we're going to convert it to a block body. And we are going to, just before calling run app, also call configure injection. And now we need to pass in an environment, and we're going to pass in our env.prod for now. So we're going to be running under the production environment. And by the way, we have created our own env class. I always like to do that, but you can also use a predefined environment class, which is actually coming from the injectable package itself, and that also defines development and production constants for those strings. We are using our own env class because when you want to have more than just production and development, it's beneficial to have them under one class. So we are going to be able to expand our env abstract class with new constants as we wish in the future. All right, so this is all for the most basic setup. Now let's get to annotate the classes. This is what you came here for, because you do not want to register factories and singletons manually, but instead let code generation do the job for you in a fraction of the time. So let's start off inside iCounter repository. We're going to annotate it with injectable. And because this is just an abstract class, it doesn't have any implementation itself. So we need to bind this abstract type, iCounter repository, to its respective implementation based on the environment under which we are currently running. So as you know by now, we are having two environments here, dev and prod. And whenever we are running under the production environment, we want to associate iCounter repository with its production implementation. And then of course, under development environment, we want to associate iCounter repository with its dev counter repository implementation. So let's do just that. We're going to annotate this abstract class with add bind dot to type. We're going to bind it to dev counter repository whenever we are running under environment env dot, after we import it, env dot dev. And then similarly, we're going to associate it with the production counter repository whenever we are running under env.prod. Cool. So because we are running the code generation with the watch command, the code has been generated for us. And we can see that now we have environment dev. And when we register dev dependencies, we register iCounter repository, which will return us an instance of dev counter repository, and similar for the production environment. We currently have a few errors here because these classes are not imported to this file. We are going to fix this right now. But before we fix it, let me just tell you that apart from injectable, which generates a factory, as you can see, you can also use add singleton instead of injectable, or there is also lazy singleton, like this. But we are using factories here. Okay, so to get rid of the errors which are currently in the generated file, we also need to mark our implementations of iCounter repository with add injectable. So this goes for the production implementation and also for the development implementation. So this step has just added the appropriate import statements to our generated injection file. So we no longer get errors when we are right here trying to instantiate a dev counter repository or a counter repository. But secondly, what this did is that we are now going to be able to resolve our concrete class implementations regardless of the development environment under which we are running. Because if you take a look at this, under dev environment, the generated code registers a factory, so that when we request iCounter repository abstract class, we are going to get the dev implementation. Under production environment, when we request the abstract class, we are going to get the production implementation. But outside of any environment, we have also registered factories for the actual implementation types, so that when we request def counter repository directly and not the I counter repository, we are still going to get the def counter repository. Make sense? I hope so. Let's move on. The last class we want to register is the change notifier. So let's go right there, annotate it with @injectable. And if you take a look at this class, there is something different about it from the repositories. That's because this class has a constructor, and this constructor takes in an iCounter repository. And this is what is so amazingly powerful about Injectable. It's going to take a look at this constructor and resolve what needs to be passed in for you. So if we now take a look at the injection iconfig.dart file, we can see that we have now registered a factory of type counter change notifier, and it automatically passes in the iCounter repository to this change notifier instance. We didn't need to do a thing. It automatically resolved what needs to be passed into the constructor, and depending on the environment under which we are running, an appropriate instance of it is going to be passed in. All right, so now we have everything in place, and all we need to do is, of course, close all of these files and go to main.dart. And now, instead of resolving everything manually, we are instead going to delete the manual instantiation and use getit, which comes from the generated file right here. We're going to use just regular getit syntax to get counter change notifier. And that's about it. Now when we hard restart the app and open it up, because we are running under production environment, we should get an app which increments the counter by 1, but apparently we have to do something more than just hot restarting. Maybe try once more to hot restart. Nope, it doesn't work. Huh. Well, it definitely should work, so we just probably need to completely stop the app. Oh, of course! We cannot run the app because we have just added dependencies but didn't restart the app. All right. After the app is completely restarted, we are gonna be able to see the app. That's awesome. And now when we increment the counter, it's going to be incremented by just 1. And when we change the production environment to be development environment, and now hot restart with Control-Shift F5, the counter will be incremented by 2, as it should be. But now let's go on to a bonus. And I know that this is just a silly counter app example, but you can probably imagine that the production environment would communicate with production APIs containing actual user data, and the development environment would operate with something where it's, safe to delete everything from the database without having a backup, because why not? We are just under development environment. We should not care about consequences. In production environment, you probably want to care about consequences, so that's the difference in between these environments. And now for a bonus, test environment, because as you know, doing test-driven development or just testing your code after it has been written, yuck, has benefits from using mocks. And if you've ever mocked something, you know how time-consuming it is to create mock classes manually. And thankfully, Injectable and its environments can help even with testing. So this is just going to be a quick run through. We are not going to actually test anything. I'm just going to show you the basic structure of what you can use when you want to use Injectable even in your tests. And I'm using it right now and I cannot praise it enough. So in order to create a mock, we first need to add a Mockito dependency to our dev dependencies. This is just going to be really a quick run through. And if you want to get all of the code I'm about to create right now, you can do so from the written tutorial, which you can get from the link in the video description. So after having Mockito as a dev dependency, we are going to go to our injection.dart file and add another environment there. It's going to be a test environment. Okay, so let's do just that. And after having a test environment, we are going to create a new file under infrastructure. It's going to be called mock counter repository. You may be used to creating mock classes right inside your test files, but I think that creating them besides your actual implementations of your classes is a much better option, because you're going to be able to find them easily. And when you need to use your mock throughout multiple test files, you're not going to have to duplicate your mock code. All right, so we are going to create a class mock counter repository, and it will extend mock. Let's import mock if we could somehow. All right, we'll do it later. And it will implement counter repository. Okay, can we import mock? No, we cannot, which is unfortunate. So we are probably gonna have to import the package Makito manually for some reason. Maybe because we are not inside a test file, that could be it. So package Makito /Makito.dart, and now we are talking. Of course, we are gonna mark it with @injectable. And now we are sort of done. Of course, we also need to go to the abstract class and bind it to another type, which will be mock counter repository. Let's import that, and this will be registered under the test environment. Cool. So if we go to the generated file, we can see that now we should also have a test environment somewhere in there. We don't have it. Okay, so we need to rerun the watch command in the console. And now we are talking. The test environment has just been added, and as with all of the other environments, it has registered the mock counter repository to be gotten whenever we request counter repository. And this is very, very cool, because now we can go to our test folder, create, for example, an example test.dart, and inside of it, I'm just going to create a basic test boilerplate just to show you what to do in your tests. We are not actually going to test anything substantial here. So I have a handy code snippet, tscaffold, and we are now going to create our class mock something right here, because we have just created a mock class inside a separate file. So all we need to do here is to create a method called setupAll, which is run before all of the tests. And now here we are going to say configure injection and pass in env, which is actually the environment constant, and is going to be test. This is the same function we are calling from the regular main.dart with development or production environment, but from our test files, we're going to call this function with the test environment. And now we can have a test. So some sort of a test should do something. And inside the arrange step for the test, we can just get the mock counter repository and set it equal to be get it, and we can just use get it as usual. So we want to get counter repository, and now we can mock everything. So when mock counter repository dot get increment, we can then return 123 will be the increment inside the test. Then we're going to do some action here. All right, so let's pretend that we have just called something on our change notifier or whatever. And now we can verify as usual that mock count repository get increment has been called, I don't know, 10 times or something like that. And again, this may seem like over-engineering right inside this app, but you mostly do not have just one mock per test. You have like 3 mocked classes per test, and when you have something 3 times, you have to create a class 3 times above the main method inside your test file, and you have to instantiate all of the classes inside your setup methods and do all of that stupid stuff over and over again. Having it done just once and then just using get-it as usual is absolutely amazing. So, as you know, the amount of boilerplate and maintenance nightmare that's prevented by using the injectable package is totally incredible. You are literally just 1 or 2 simple annotations away from having a robust dependency injection system working with the battle-tested get-it package in place. So use it and save your time. And to go through this tutorial at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, links also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you with understanding injectable package or dependency injection in general with get-it, give it a like and also share it with your fellow app developers who will surely benefit from this video too. Leave a comment if you have anything to say, and see you in the next video.